Yeah, Vikram,
Okay.
I are now 76 people, including
Okay.
two of us, so 74 people.
Okay, great.
You want to start the recording?
Yeah, I've started the recording.
Okay, okay.
Okay. Uh, Jimmy, can you take attendance or you are not? You don't have the permission to take attendance.
Later, later.
Okay. I've taken one, so we'll take it later. So we had stopped over here last time, where we talked about the foundations and the challenges of foundations and the soil bulk pressure, as well as the bearing stratas and how the foundations actually behave. And today, what we are going to talk about is when. Hello. Today, what we are going to talk about is when these, instead of foundations, we have basements themselves. What are the challenges that we face, both structurally as well as construction wise? What are the challenges that we? So we are going to discuss a bit about that, and what are the alternatives, or what are the ways in which basement construction is handled? Mind you, last time itself I had told you that basement construction particularly offsets a building cost. If it is a ground plus 7-story building and all, if roughly the cost of the project is about 5 crores or something construction cost, a typical basement of this kind will be nothing less than 1.5 crores. So you're talking about nothing less than 40%, means if it is 5 crores is full finishes and everything, but the construction cost itself might be 3.5 crores. So the basement, if the basement itself is going to about 1.5 crore, so the project cost, the basement cost is almost anywhere between 40% to 60% of the construction cost of the raw shell. Yeah. So that is the significance of this topic. Now, why would you go for a basement? There are so many challenges with it. Why would you go for a basement? Anyway, before we get into that, uh, see, I tried to locate many years back when I was trying to prepare for this, and even today, as on date, there is an update in the Indian codes up to 2018. But the design parameters for basements, they are not stipulated. Most of the Indian codes, they mention joineries, structural systems, superstructures, staircase, everything, all the circulation part of it. But waterproofing as a material, they have covered. They have covered materials which are used in basement, the RCC and all. In terms of element, they have covered in the building codes. But the design of the basement itself has not been covered in the Indian codes. So that's why we are referring to the British standards over here. So, according to this, and this is very important because in our context also, we are increasingly, because of the scarcity of space, particularly in Mumbai and metropolitan cities all over India, we are increasingly seeing a lot of basements being constructed. So, let's understand what are the standards, what are the requirements of a basement, and how do you go ahead designing a basement, right? So the British standards spells out 4 grades of basement. The first grade is that of a basic utility, which is a car parking, plant rooms, which should not obviously have electrical equipments, mechanical equipments, and other boilers and all is fine because that much amount of moisture is okay with them. Even workshops can handle a little bit of moisture and all. So there is a basic utility. Okay. Then grade number 2 is the utility is of a better quality. Okay, which means that there is a workshop and as well as plant rooms. Okay, requiring drier environment. Like for example, your laundry, laundromats, your AC, this electrical. Okay. Then the third grade is that of a habitable, ventilated residential or commercial areas. Okay. So on the right, you are seeing image. The top image is that of a car parking, which by most of the standards we go for grade 2. whenever we are constructing basements, particularly for parking, we never we don't construct for basic utility. We construct for better utility. That is grade 2. The bottom two are from the project which we did in IIT. There was a building which had a basement, and the basement had functions right from a classroom, auditorium to these peripheral spaces. Some of the spaces were given away for the laboratory. So bottom you have a SEM, the electron microscope laboratory. And so when you have these kind of requirements, okay, those are grade 4, that is controlled, special controlled environments, which means that you the ventilation has to be this. There is a air exchange that needs to be considered. So if there is an archive storage or there is a laboratory, there is a dehumidification, air conditioning, ventilation, the all the works are required in these kind of basements. So at one end, broadly, you will be constructing your basement either as grade 2, or you'll be constructing your basements as grade 4 or 3. Now, habitable, ventilated residential and commercial areas, when we say grade 3, these most of the residential areas are small. So the kind of the requirement of mechanical ventilation and all is not as intense. So even if I have a small opening and allow the ventilation to happen, I still will have a considerable amount of habitableness. Okay. But when we are talking about larger footprints of buildings, of institutions and all, the entire ventilation, mechanical dehumidification is mechanically controlled. And that's why we talk about grade 4. So in these images that you are seeing grade 2 and grade 4. Okay. Then the codes, the British codes, depending on what these functional classification is, so that is one type of classification of grades. The second criteria, they call it 3 types of water resistant construction. Now, this is mostly used for basement. It can be used for water tanks. It can be used for other functions which are underground structures. But broadly, if I apply this to the basements, there will be a type A construction, water resistance, which is only a membrane barrier, which is the most of the time we are using this either in terms of Shabad box type waterproofing, or we use it as membrane waterproofing, which are there are many materials which are elastomeric, as well as there are the flexible materials which are used, which can create a membrane either inside or outside, that we'll see. Second, B type is the structurally integral protection. So if there is a tunnel or if there is a metro station and all, obviously the waterproofing will not be done separately. The structure itself, it has integral protection for water. Okay. And there is, in addition to that, if the soil has too much of hydrostatic pressure, then you have a drained protection. So which means that you don't allow the soil, the water in the soil to build up to the extent that the soil, the hydrostatic pressure of the soil itself will collapse the building. So you try to organize a drainage around that. Okay. So these are the 2 ways in which British standards look at. Now this is the same site which we showed you last time, and if you look at very closely, you have you have this waterproofing types. Anyway, so the forms of construction to achieve the levels of water tightness which we see earlier, said earlier, is one is you definitely need a reinforced concrete box. In the older times, when the reinforced concrete was not there, and the castles and the buildings, load-bearing structures, the walls were massive. They were stone walls. They were massive walls. The waterproofing was done as the mortar used in the masonry itself was in some way it was resistant to both the hydrostatic pressure, the soil pressure, as well as the water ingress. Okay. So then you have a continuous secant pile, which we saw over here with a facing wall. So this on the right side, what you're seeing is uh, uh, this this image is continuous secant pile with a facing wall. Okay, and third type is the diaphragm walling, which probably will take it up next week. Jimmy will have a presentation for that next week. On the right, in the same project I told you last time, wherever the rocks were there, they didn't go for secant piling. So what we see over here is a masonry which is constructed so that we get a level, and inside that there is a RCC retaining wall, which is, so this thickness is different from this thickness. This is a structural RCC wall, okay. Whereas in this, the soil structure is taken care of by the secant piling, and this the retaining wall to receive the waterproofing. Yeah. Then you have other construction parameter, that is uh, what is the vapor exclusion measures which have been deployed. Okay, so depending on the environment which is required, so depending on the four grades and as well as the what is the condition of the soil outside, you might have a drained cavity system. Okay, which in Mumbai we don't see very frequently. We mostly are content with a very strong structural this, because we have a basaltic rock most of the time, and we don't have so much of sludge or hydrostatic pressure being built up. Okay. Uh, then you have an external membrane system. Okay, I'll show you the external membrane system. Then you have an internal membrane system. This is an internal membrane system where your facing is done. You have an internal membrane, and then again there will be another wall which will be constructed to protect this. Okay. Then there are active precautions like heating and ventilation systems. Yeah. So whatever uh, from the wall there might be an ingress, or even ingress might be through the air. Okay. Now it is important to understand that whenever there is a stagnant air, and a city like Mumbai, which has a humidity extending beyond 90%, the air is very high in humidity. Now, if there is a high humidity air and it gets it gets stagnated within the basement, then it is going to lead to certain fungal growth and spores. So, which is going to affect the health of that space. So, it is not enough to only waterproof your walls. It is also important for you to understand the air quality of your basements, and whether the air quality is healthy enough, or whether it is ventilated enough to remove all the fungal, or to prevent the fungal growth. Yeah. Yeah. So on the right, there is an image where the vapor barrier, which we spoke about last time in the previous slide. What happens when the vapor barrier rises through the wall? So this is an image where when the vapor barrier does not get enough room to project or come out of the mortar joints. This is a masonry construction. It's not a basement, RCC basement. But even within this, when the mortar joints are filled with cement and there is very little space for the water to move, water starts accumulating just beneath the outermost surface of the stone. And what we see over here is the stone has started flaking because there is a vapor barrier which was created just beneath the skin of the stone, and the vapor pressure is so powerful that it is able to flake the stone also. Yeah. So what are the challenges that we have? Number one is excavation volume. Okay. Now, if you look at the previous slides, you can very well imagine what is the scale of excavation. Now, it is not just excavation in terms of soil nikala area. When you talk about excavation, it is like where does the soil and the debris gets deposited. That itself is a big logistical challenge. Yeah. So you might have, so imagine the truckloads of soil which has been transported from this soil site and being shipped or being shifted somewhere. And what is the status? What is the ecological impact it has over there? Okay. So number one is the volume of excavation which has happened. Number two is the transportation of that volume of the soil from one side to the other. Number three is the cost, the labor. Number 4 is the challenges when excavating the soil as well as when the rocks have to be broken. Okay. And number 5 is uh, the time involved in doing all this. So typically a basement of this magnitude, if you want to start, generally when people say that I want to start a project, uh, and there is a basement involved, the advice is they have to start immediately after the monsoon so that the excavation, everything is taken care of, and by the time the next monsoon arrives, you have your first slab cast. So which means your basement is protected, it doesn't get inundated, because once the basement gets inundated with water, there is the construction activity stops, right? So please bear in mind, basement has huge time, cost, and logistical implications on your project. Okay, so unless there is a specific functional requirement and all, as well as there is a need for a specific footprint, please try to keep your basement to the minimum. That doesn't mean that you follow the basement to the profile of your building. No, there are other constructional issues that you need to consider, and the decisions have to be taken based on those. Yeah. Second is the soil retention. Now imagine, again, I'm going back to the previous that same slide. Imagine if these secant piling, shore piling were not there. Okay, then do you imagine the soil would have retained itself, except for, of course, over here where there was a rock over here and it was chiseled out. In this portion where the soil was, the the deeper you went, if this shore piling were not there, the soil would have started caving in. It would have been almost impossible to construct. So the challenge is up till 1.5, 1.2 meters and all, it still becomes viable for you to excavate a foundation. But once it goes to 2.4 meters and all, you'll need to figure out how to shore the soil, which means to retain the soil in its position so that the soil does not collapse. Okay, and once you go deeper than 2.4 meters and all, then you have to take all the precautions. At one of the sites where we did, Sandhya and myself, we did in Carmichael Road, we had a challenge where we didn't our geotechnical consultant as well as structural consultant, they were very confident. They said there's no need for a shore piling uh, uh, for two reasons. So one was because we were not taking the excavation during the monsoons, it was during the dry period. We were going to have the entire foundation created. Now this foundation was excavated almost 3.5 below the ground, and yet we didn't require the shore piling, so it was done without the shore piling. Okay, so it is not necessary that because you have gone to 3.5 meter, you will need a shore piling. It's not like that. It is depending on the ground condition, particularly in the Jew scheme area, you have a lot of reclaimed soil. So where the soil is very, it is not consolidated. And that's the reason even at shallow depths, you require some amount of shoring. Yeah. Uh, that is, but we did require shoring of the soil, not shore piling, but we did require a shoring of the pile. I'll take a small pause over here if there are some questions, because otherwise I'm not able to see your screen. I'll just sit over here. Yeah. Are there any questions? Pushes the stone masonry over time though. Yeah, no, the stone masonry vapor pressure, it's not. See, vapor pressure is when water gets trapped into the stone masonry or the concrete masonry. If it gets trapped and because of the heat, it is forming a vapor, then it will expand. Okay, so that's why it will chip off the surface. Whereas when you are talking about stone masonry getting pushed, the stone masonry getting pushed is because of the hydrostatic pressure. It is not because of the vapor pressure. Okay. So hydrostatic pressure is the amount of groundwater which is getting mixed up with the soil and making the soil as a sludge, as a non-consolidated kind of sludge. So the weight is not only equivalent to the weight is equivalent to the water, but the behavior is that of weight is equivalent to the soil, but the behavior is that of water. So that is the reason why your walls collapse. Yeah.
Vikram, we are not able to see your screen.
No,
We are able, ah,
I'm reading the chat box. That's why I'm not. So because I have to toggle between these two windows. Can you explain secant piling part again, please? Okay. Yeah. So yeah. Apart from these are there any questions? Because once I go back to the window, I won't be able to see the chat box.
Vikram,
Yeah.
in the basement part, if the
Uh,
basement is huge and massive, like it's for some township build up or some commercial purpose, and if the basement is going like 2 stories or more than 2 stories, then is
hmm.
it possible to get it done before next monsoon?
When there are 2 to 3 stories and for example metro work is going on below at a depth of about 23 meters. Okay, the bottom of the metro station is at the depth of 23 meters. It has been going on for the past 4 years, but they have made temporary arrangements for the top layer so that even vehicles are passing. So underneath they are doing their work and everything, but they have made provisions so that there is. See, you must remember that any of these sites, if you want to keep it active during the monsoon and you don't want to lose it, then you have to be in a position to arrange for the the removal of water, whether through pumping uh, at the pace which is much higher than that of the rain, which means that if you put a cover on it and the water and there is a water barrier from the sides and you don't allow the water to come in and you cover it from the top, you can still continue your activities. Okay, so there are. I don't know whether I have answered your question, but typically, if you don't want to end up those costs. You try to speed up your construction activity so that you are able to finish before the monsoon. If you hit the monsoon, many a times the pace of the work becomes slower, or if the water is inundated and the pumps are not working and or the pumps are not moving at the same pace, or they are not able to flush out the water at the same pace, then you have a issue over there. So it is always advisable to make all the provisions in preparation of the monsoon, including the side waterproofing. Okay. Can you explain secant piling part again? That is one. Do you repeat what vapor barrier is and how to prevent it from affecting the masonry? Okay. Is there any method which can replace the stone which is decayed? Sorry, or got affected with water pressure, or how to repair it? That's not the scope of our today's work. This if you can do conservation course, I'll explain you that. uh, yeah, otherwise I'll explain you separately, not as part of this class. uh, Vapor barrier is okay. So there are two questions that I'll take up. Secant piling part again, and the vapor barrier. Okay. Okay. Now, when we looked at sorry, when we looked at last time when we were looking at this, we saw these sheet piles, right? Okay. Now, sheet piles are different from your load bearing or end piles or friction piles or soil compactor piles. Now, this is a whole category of piles which includes secant pile. Means this is how the pile behaves structurally. Okay, it is continuous sheet, but it includes the whole category of whether you call it secant pile, whether you call it shore pile, or you call it diaphragm walls. All of that gets included over there. Now, the details of that I'll cover it between Jimmy and myself when we are looking at diaphragm walls and the pile, the secant shore piling. We'll cover that. Uh, does that answer that question? Okay. And regarding the vapor pressure, yeah, regarding the vapor pressure, see, many a times you will come across buildings which are 100 years, 200 years old, and they on the plinth level, if they are not breathing or they are continuously, if their joints are sealed with cement particularly, you will you will see a lot of flaking of the stone surface. Okay. Now, what is the reason of this flaking of the stone surface? There is, you very well are aware that we in your first and second year you have studied the damp proof course, right? Now, damp proof course prevents the water from going onto the wall above, but up to the plinth level, the water is very much there. Also, if the dam proof course gets broken, the water, because of capillary, it will rise above into the masonry. Now, the water is rising above at the middle, but water will always have a tendency to get attracted towards the surface. Why? Because there is a evaporation on the surface. Okay, this evaporation, because this surface is exposed to the heat, to the sunlight and heat. Okay, and because of this evaporation, the water will always try to, along with the salts in it, it will always try to come and deposit on the surface. So it will have a tendency to come outside the surface. Now, what if somebody has put a waterproofing coat on this stone, or for that matter, if the stone itself, the surface of the stone does not allow the water to come out. Okay, not only that, even the joint of this stone masonry is, instead of lime mortar, which is porous and it will allow the water to come out, if the joint of this masonry is in cement, which does not allow water to come out, then what will happen? Then what will happen is the water will start becoming vapor beneath the surface of the skin of the building, of the material. Now, when water starts becoming a vapor in just beneath the surface of the building, it will start exerting a lot of pressure on both sides, on the outer skin as well as on the inner stone. So that is how this portion will start flaking. This is not only true for stone, it is true for cement also. Okay, so we need to understand the nature, how the water. So water is not just about plain water, it is also about hydrostatic kind of pressure that it is going to have. It is also about the vapor pressures that it is going to have. It is also about the moisture which is going to lead to the fungal growth or the conditions of the basement. So water has to be seen in multiple ways and not just as waterproofing or water prevention. Okay, does that answer the question, or shall we move ahead? Okay, so we'll move ahead. I'll just, okay. Now, this is a site we did in IIT. It was a old students activity area, and it was given away to the bank for constructing its vault. So the the thing was, it was not only about retrofitting a structure, but it also meant that we had to do the waterproofing of it, because there were locker rooms it was a semi basement. I wouldn't call it a complete basement. One side was completely below ground, but the other side it had some space. But there was the biggest challenge which we were not aware when we started the project, was that there was a groundwater rise. The groundwater rise in during the flood seasons, during the it was very high. So which meant that there was a lot of hydrostatic or upthrust of the groundwater itself. So it is just like, imagine that you have to construct a boat in the water. That kind of a pressure, that, and if there was any hole in the boat, then the water is going to come in. So now we had to do this retrofit of an existing structure, which was which was not waterproof. It had masonry walls, so we had to break down the masonry walls. It had regular PCC, so on the in the floor, so we had to break down the PCC. In fact, it had plinth beams. We had to break down the PCC, the plinth beams, because we required a solid raft over there. Okay, of course, the reinforcement had to be integrated with the raft itself. But on the right, what you're seeing on the top image, this one is the external waterproofing. So we constructed the RCC wall, and there was a waterproofing on the external side. This image is over here. It is looking from over here. So in this image, there was this existing retaining wall. Okay, and there was this new 150 RCC wall that we proposed, okay, as part of the strong room, and the waterproofing had to be done on this side. So this portion, this wall had to be broken off. So we broke off this portion of the wall as well as on the other side. And again, see, please remember, the waterproofing has to be continuous. It has to be continuous on all sides, right? So I cannot have on this surface waterproofing from outside, but on the other surface waterproofing from inside. Okay, so that will mean that there is a, if I put waterproofing on this side and on this side I put waterproofing from inside, which will mean that there is a vulnerability at this junction. Yeah, got it? Yeah. So it was important that whatever we chose to do waterproofing over here, we had to continue the same waterproofing over here, as well as before the raft was constructed, we had to construct the waterproofing on the floor. Not only that, in this particular case, I don't have the drawings for, I'm not showing the drawings for that, but in this particular case, we also had to lay down drainage channels, drainage pipes over here, as well as over here. We had to layer it with a gravel layer, so that all the groundwater which came over here, it could be drained off into a sump over here, and then it could be pumped away. Yeah. So that was the extent to which we had to elaborately detail out this basement. Now these are just few of the drawings that I'm showing you. This was that structure. So upper part was the regular bank, and the lower part was the strong room, with the cash rooms as well as the locker rooms and all that. So this was supposed to be waterproof. So these beams, the existing beams, had to be broken. The concrete had to be removed, and we had to cast the whole slab as one solid raft. Okay. We had to waterproof the outside. I have already discussed that. Okay, and this was the existing retaining wall foundation. Okay, and the toe was in this way. So we had to construct the raft like this, in this manner. Yeah. Now I'll just, so is there any, you want to spend a little more time on the nature of waterproofing, you know? You have understood the external waterproofing. Now this is also called box type waterproofing. Okay, now this is still very much practiced across. but internationally, European countries as well as now, we have other materials also. We have membranes. Okay. Now membranes can be brush application. They are formed. They are in the sheet rolled. There is DuPont has this. There are chemical applications, but uh, many a times what happens is chemical waterproofing requires a very high amount of skill. Not only that, chemical waterproofing over a period of time, 15 years and all, there are many products which have not been time tested. So we really don't know how they will react with acidic nature of the soil or the organisms within the soil, and whether they will have vulnerability of it. So that's why tradition this type of waterproofing is time tested, and we most of the time wherever we get an opportunity, we go for this type of waterproofing, and we use the membrane waterproofing or the chemical waterproofing only in cases, situations, challenges where this type of waterproofing is not possible, either because of the site constraints or because of the availability of the stone or because of the lack of availability of skilled artisans to do this kind of waterproofing. So for various reasons, if this is not feasible and the other waterproofing is much more possible and doable, then we shift from this. Otherwise, most of the time you will see this kind of waterproofing. Now this has two layers of stone. Okay, I don't know if you are able to see this, but this line is, there are two layers. Sometimes it is a single layer, sometimes it is a two-layer stone. Okay, so at every junction, every joint beneath that there will be another stone. So depending on the kind of water tightness that you want to have, you can have single or double layer of these box types. Yeah. Yeah. So now coming to the when you want to design a basement, what are the planning? What are the considerations that one needs to give? Okay. So number one is the basement. What are the functions that you are going to? As I said, basements are very expensive. Until you are clear that this is the kind of usage that you are going to put your basement to, there's no reason, there's no purpose why there's no reason why you should spend that almost 40% extra. Yeah. uh, like 40% would mean that if the project is 10 crores and you are spending 4 crores just on the basement, it doesn't make sense. Yeah. So you have to be very clear what is the functions that you're going to accommodate within the basement, as well as how you are going to have the circulation organized. So for example, if it is just what I did for the bank, if it is a vault and all, the access to the vault, the circulation, so entire planning design of not only the basement structural walls, but also the how the functions are going to be catered to. In your case, many times you will have services accommodated over there, fire services. So you will have administration office, a security office, or you will have the rest areas of the it's just the sleeping areas of drivers or maids, and so there are so many functions which can go into the basement. Apart from the most common one, which is the parking area. So in Mumbai, we are crazy for parking, and we want to have lots of parking areas. In future, we might also consider this kind of waterproofing if there is something went wrong. You are not able to hear me?
Now we can. Earlier we were not able to.
How long did you stop hearing me?
5-10 seconds
Parking,
only.
crazy for parking.
Sorry.
No, Vikram, you're clear. Please continue.
So, yeah, so there is a possibility that just like old times where basements in Ahmedabad as well as in Kaneri and all, you had the water storage, a reservoir is constructed over there, or you have in nowadays when we're talking about sustainable this, and you have solid waste management plants and water recycling plants, all of these functions are being considered being accommodated within the basements. Yeah. So apart from your central air conditioning, apart from your electrical, apart from your telephone networking and all that, security, you have other functions also being considered in the basement. So please list down all the functions as well as the circulation. Circulation would also mean not only a regular day-to-day circulation, but also in case of disaster, in case of emergency, how does the evacuation happen in the basement. So it is a very important part of it. So both the functions that are accommodated within the basement as well as the circulation of the basement, both vehicular as well as into a pedestrian, that needs to be taken into consideration. The next is the location of the staircase, lifts and ramps. Now why I have separated it out from the circulation and functions is simply because structurally, sorry, there is a spelling mistake over there. Structurally, there is the lifts are going to have a different kind of a pile cap and foundation, which is going to be a challenge for the construction of the basement because of the waterproofing. The ramps also are going to, there is, you have to decide whether the ramp is within the retaining wall limits of the basement or they are outside. If they are within the retaining wall limits, structurally, how is the ramp supported? You need to have beams, you need to have columns. So most of the time students are missing that. So ramps are shown without any thought to how structurally the ramp is going to get constructed. Yeah. So that's the reason why I'm emphasizing it separately here. So also the staircase, the location of the staircase, because staircase, even if the lifts, many a times lifts don't go down to the basement, or not all lifts go down to the basement, but the lift shaft structurally have to go down to the basement because your the raft or the pile cap will all be cast at the same level. So it is important to understand how the lift shafts and the basement raft engages with each other, as well as how does the staircase connect to the basement raft together. Okay. Apart from that, you have the biggest challenge, which you in fact you start with, is the alignment of the structural grid of the superstructure and the basement. Okay. I'll just go a little ahead. Now, this is a ground floor plan. Of course, this is a student work, so obviously there are a lot of, professionally once it goes, a lot of it will be cleaned out. You won't have these jagged kind of edges for the basement and all. But nevertheless, the student has attempted to show that there is this, there is a ramp which is going and there is a ramp which is coming out from over here. Okay, so there is an exit, entry and exit over here. There is a ground floor grid. Okay, when they started off last year and they hadn't thought about the basements, at that time these grids were quite different. Okay, they didn't follow, they didn't really align to the basement grids above, below. Okay, as we worked with them and developed this, they had to make sure that the superstructure grid, for example, over here you have very close columns to each other. Over here they are placed far away from each other. So the circulation of these cars, they have to align to the structural grid, which is actually influenced by the superstructure, and also the basement many a times influences the superstructure grid. So please remember, whenever you are starting a project, also give a thought to if in the future there is a basement which is added along your project time itself, design stage itself, what is the grid changes that you are going to have. Okay, so please do not, and even now when you have designed your superstructure maybe with 4.5 meter by 4.5 meter grid, how does that translate into the basement in such a way that it will still allow for the car parking is a big challenge. It's not easy to resolve that. Okay, so that's what we meant by structural alignment with the superstructure. Then you had drainage and sump location. I don't know if I have taken the image. I'll show some other images over there. Now, Jimmy did send me, but I haven't put it over here. I'll just try to share that over there. Now, please remember that the water is going to come either along the car through the ramp, okay, or it is going to come when you are washing the cars in the basement, or it is going to come through if there is a breach of waterproofing, the water is going to get accumulated over there. There might be dampness. It is important to have a drainage pattern planned for this, so that it is, it is directed to a certain, maybe one or two sumps, singular locations within the basement from where it will be pumped out. Okay, so okay, now yeah, drainage and some. Then you have light and ventilation. Now, earlier the basements, it was compulsory to have natural light and ventilation for the basements, where the first was constructed at about 1.2 meters, and the light and ventilation was drawn from the sides. Okay, so there was a race. Over a period of time in the past 30 years, almost 25-30 years, we are seeing a number of projects where you don't see any of those side windows for your basement, and they are completely sealed off, because we are increasingly dependent on the mechanical light and ventilation. So in your services, you will study this. Particularly at this point, I'll just leave it saying that uh, try to understand ventilation. Light, so obviously you're going to have LEDs and all those things, but ventilation will have a fresh air inlet side, which mostly is from the ramp, because ramp is open and it is large and it has a huge volume of opening over there, and the exhaust will be in the diagonally opposite side, and in between you will either have, directional kind of jet propulsion systems or ducting systems, or you might have a number of systems which you will study in the services, but there has to be a fresh air provision, fresh air inlet provision, and there has to be a exhaust air outlet provision. Okay, so that is that. Then coming to this section again, by this is one of the student work, Sanket. Uh, of course, the drawing over here, the beams and the slabs are, they are not merging with each other. There's a problem over there. But the point is, the caps are shown above, so the raft and the waterproofing is continuous. Just to understand what are the layers of the sequence of operation, you have the piles which are dug over here. The piles may come all the way up till over here, or they might stop up till over here, and you have an excavation. So you have a broad excavation done over here. Okay. After the excavation is done, you will have the stone, or you will have a stone pitching which is done. Now over here, the student has shown almost the soling. A soling is not required. Soling is never required in basement, because the raft itself is a structural element, and you don't need that additional depth of stone. This is required only to create a dry barrier. So as much as 100-150 is good enough. A stone pitching of 100-150 is good enough. Yeah. Above the stone pitching, you're going to have a PCC layer. Okay. So PCC is going to be placed so that you have a level surface. Now above the PCC layer, you're going to have a Shabad, or I'm talking about box type waterproofing. If you don't go for box type waterproofing, if it is a membrane waterproofing, you will apply a membrane layer. Okay, but we'll stick to Shabad waterproofing for this. So you have Shabad waterproofing. This Shabad waterproofing will stop over here. Then you will try to construct the sides. So these are the masonry which will construct the sides, which will, whenever the pour is happening of the raft slab, the pour cannot ooze out. So you have a construction of the sides. So this masonry also allows you to have the vertical waterproofing of the box, which is continuing upwards. Okay. Once this waterproofing is done, then the steel of the raft is laid, raft as well as the beams, raft beams. Now, in this case, the student has shown beam and slab raft. Okay. Many a times you will go across for a solid raft also. So I'm sure you have studied solid raft and beam and slab raft in your third year. So uh, now once that reinforcement is laid, then the concrete, the design concrete is poured. So either it is M25, M40, whatever design concrete your structural consultant has specified, will be poured. And once this is poured, it will have a tack layer over here and the reinforcement which will be coming out. And while this is under construction, the student has not shown the construction joints or vapor barriers. So there are construction joints which are with vapor barriers over there. So at every 1200 intervals, you will have these these barriers. Okay. uh, for the construction, and either this waterproofing will be done from outside, or if it is not possible, there will be a masonry over here. Just similar way, the waterproofing will be done from this side, and then the retaining wall will be constructed. Yeah, that is the sequence of operation over for the basement.
Hello,
I'll take a pause over here.
Vikram.
Yeah.
Can you repeat this wall section again? It's quite difficult to hear you and it's quite fast.
What were you not able to hear?
Actually, I was confused with the layers below. I wanted to see it, but since your screen is small, we can't see the everything. Can you just zoom into that particular part and then try to tell? It will be more good that way.
Is it better, or you want a bigger one?
A little zoom. That's it.
Hmm. Is that fine?
Yeah,
Is that
fine.
fine?
Yeah.
Okay. Now,
Vikram,
this is a student.
Vikram, if you don't mind, usually this concept which we adopt is that getting the pile cap on top of the raft. You need perhaps they've not neither designed the basement, and so this is a wonderful link them enlarge hai, so they can see. And this idea of the pile cap on top of the raft in order to get seamless waterproof. I think you covered it, but because they're introduced to it for the first time, they may not be able to register the importance of that.
Okay. See, first of all, a disclaimer: this is a student work, so there are errors in the drawing. So we are not and there are obvious kind of errors, graphical as well as constructional errors over here. But I'll just attempt with this drawing. Yeah. If you look at the sequence of operation, you have piles over here. Okay, so the piles will be driven. Now the pile, obviously, either I'll construct the pile at this level from the ground level itself. Okay, so if I'm constructing from the ground level, when the excavation starts and I reach over here, this portion of the pile will be broken off. Okay, so that is one challenge. Or I decide ki, okay, this file anyway I have to construct over here. So, and the adjacent building is very far away. So I can do a inclined excavation up till over here. And some way I figure out that my vehicle, my piling machinery can come down and I'm able to make the pile from this level. So whichever is the case is, that is one. Or I leave the tubes which are hollow and fill the concrete only up to a certain level, and then I wait and once this whole thing is done, I just remove the tube, the top tubes. So that is one process of construction part, the first part. So piling, whichever way, we need the pile only up till over here. So the reinforcements have to be embedded within the pile cap. You remember this? I'll just no, I might miss the zoom of this. I'll go back to the that particular slide. Now, after the piles are laid, the pile cap is going to be constructed along with the raft as well as the beam. They are going to be cast as monolith. Okay. So which means that I have to prepare the ground for receiving the raft. Okay. Now how do I prepare the ground? Number one is I need a dry stone pitching so that my cement and water does not leach out into the soil. Okay. So over here, it has been shown as 230, 300. Probably it is not required. It is overkill. You might just require about 100, 150 mm of this layer. Okay, on which you have this PCC. The PCC is important because you need a level surface, okay, for your waterproofing to be done. Now, once the PCC is done, it is cured, you have a level surface, you have a surface to work on. You will have this layer, which is your shower waterproofing or box type waterproofing. So you'll have shower layer, where the joints are also filled up with the waterproofing compound. You might have single, mostly it will be double layer, where the joints are also sealed off. Okay. Once you reach over here, you will also need a masonry over here so that the waterproofing can turn up. Okay. So the shower waterproofing will turn up. And after the shower waterproofing has turned up, because this is where the concrete is going to pour and the concrete should not be allowed to spread out. Okay. So after this, the shower waterproofing is done, then you will start laying your steel of either the solid raft or beam and slab raft. So the steel of raft, the beams, the tie beams, as well as the pile cap, all of the reinforcement will be tied, or they will be they will be installed in place. They will be tied in place in one go. Okay. There will also be a reinforcement which the retaining wall of the basement, that reinforcement also will come out. It will project out. Okay, and it will be left like that. Okay. Just a second. Yes. Nine. Yeah. So yeah, I was saying. So once the reinforcement is in place and the shuttering of the pile cap is in place, so now the shuttering of the pile cap becomes difficult. So you might consider the pile cap being cast first, okay, and the beam and the raft being cast together. Okay. So there are, but then it will lead to construction joints. So depending on which contractor, which agency, how they are able to work out their shuttering of the pile caps and all, they will phase out this construction process in a sequence. So once the raft is in place and there is the reinforcement which is over here for the plinth, plinth beams, as well as the tie beams, as well as the pile cap reinforcement also in place. The second stage would be to extend this waterproofing further. Now, how do you extend the waterproofing further? This is only when you do not have the possibility of waterproofing from outside. If the possibility of waterproofing from outside is not there and you have to waterproof from inside, then you have to construct this wall. Now, the student has drawn this wall as a very thin. It's supposed to be thicker. Otherwise, it will not be able to hold the soil. Okay. So it's supposed to be thicker with the piers and everything. And you can do the waterproofing extend further up. Once the waterproofing is done over there, then this reinforcement, the retaining wall reinforcement is taken up, and you start pouring the concrete layer by layer. So the concrete will be poured at every 1200. So every 1200 you will have a barrier, the construction joint. Now this construction joint will be sealed off by a vapor barrier. Yeah. Now over here, there is about the pile cap. The concrete extends a little further. Now this, uh, if you look at this hatch is a design concrete, whereas this portion is the lean concrete. Now lean concrete is, as I told you last time, it is it does two functions. One is it levels the surface as well as it provides the ballast. Ballast is important for many high rises as well as many buildings, so that your building foundation is stable and it remains stable throughout. It doesn't have any undulation, or it doesn't it doesn't sway, or it doesn't tend the building to uproot itself. Okay. So within this, in fact, this is also incorrect. This drainage channel should be away from the pile cap. It should be over here. So this channel will be draining out all the fluid, and it will be laid to a slope. So if you, even if you consider 1:60 slope or 1:100 slope across a 60 meters span, or 100 meters span, wherever the sump is, your depth is going considerable. So you will, depending on how big your this is, and because depending on this, you will lay out a drainage system, which will, or you will have multiple sumps which will be located in different portions of your basement. But it is important to know that this cannot conflict with this pile cap. Okay, so it has to be moved away from the pile cap. Okay. Yeah. And this is a scupper. Scupper is another, it is a drainage pattern only, but instead of deep channel, you have a scupper, just an aluminum kind of thing, which then it has pits. That portion we'll cover maybe later. Are we, is there any other question?
No.
Could you share the PPT in the beginning of the lecture? That the video lags quite enough and we miss out most of the explanation that it is done. Oh, sorry. Yeah, next time I'll do that. But is there is a lag in my video, or in some, everybody has this lag, or some people have this lag?
No, no, like we might see lag due to our networks, but yeah.
Okay.
No, there is no lag. Otherwise, it's fine. Vikram, you need to take the attendance.
Yeah. Okay, so that's that for today.
Vikram,
Any questions? Yeah.
can you go back to that wall section and explain where the drainage thing was happening that I didn't understand? By the car. There is written 600 mm.
This one?
On the right, towards right. Yeah. What were you telling? Yeah, here. Exactly.
See, there we realize that if I go back to just a sec, this slide. No, it's false. If we go to this slide, okay, I'll just try to retrieve from my downloads. See, if you look at this basement, okay, if you look at the figures below, it's 1, 2, 3, 4, 5, 6, 7, 8. 8 into 6, 48 meters, approximately 48 by or 50 by 50 meters. Okay. Now, if I consider that all my water is going to come from over here, okay, this channel, okay, and if I keep a sump over here, okay, it will mean that if there is a water ingress through the staircase or the duct which is over here, or there is a car washed over here, the water which will be accumulated over here to reach out to this place, it will have to traverse more than 70 meters, right? Now, if we consider 70 meters, and by a slope of even calculation purpose, if we consider a slope of gradient of 1 is to 100, 70 meters would mean 700 mm. Yeah. So,
Yeah.
so the by the time you reach over here, your depth of your gutter channel is going to be 700 mm. Okay, which will mean that you have to put additional 700 mm concrete to accommodate that gutter which is above the beam, because you cannot conflict with the beams, nor can you conflict with the pile caps, right? So because of that, it is important to understand the portion and what is the shortest route. How can you reduce this length?
Vikram, we can't hear you.
Am I not audible to anybody, or?
Dharya, mute yourself.
Okay. So in this case, ideally what in this case, ideally what should be happening is you should have one sump over here, one sump maybe over here, or you can have one sump over here, one sump over here. Okay, so that you can lay a drainage over here this way, going this way, and one drainage going this way. So this anyway is a shorter route. So you are reducing the length from 70 meters to maybe just 40 meters. Okay, first, number one. But even 40 meters is very high. So 40 meters would give you a depth of 400 mm. So 400 mm over here would mean that you have 400 mm of additional concrete just to accommodate your gutter. Yeah. So now those are the challenges that you face. Now there are people who try to accommodate pipes, drainage pipes through the beams, drainage pipe through the beams, and lay to a slope, and then they just put a scupper on the top, so that the scupper is what I showed you in sorry. Okay, in this portion, this part of it is a very shallow one. So it is roughly, it is just an aluminum profile which you see on your airport when you go to the T2 or any of these. There are these aluminum profiles even in the basements of the malls. When you go to, there are these aluminum profiles which channel water, but they do not have the capacity for accommodating all the water. So what they do is they divert the water to the nearest chamber. There is a chamber. So this system is different from this system. This system is complete drainage channel which will lead by gravity to the sump. Whereas in this system, the scupper will channel all the water to a pipe, a drainage system which is embedded within the concrete. Now that at the junctions of all those drainage pipes will be accessible from the top. So it is a concealed pipe water system which will then lead the water to the sump, and from the sump it will be taken away outside. Now what Jimmy was asking was whether the pile cap will always be above the ground or it can also be below. Now as we say that so this depth is determined by what is the ballast, what is the concrete you want to pour, all of that. But whereas this pile cap is determined by the load which is coming on the pile cap. Now, if there is the column load as well as there is a upthrust which is coming from the bottom, this pile cap will have a certain depth. Now, that depth might not be matching with the depth of the raft itself. So, in which case you got to decide whether the pile cap is projecting up, or in this case, this is because it's a student work, they have conveniently accommodated the pile over here and not bothered about how much depth is it, because the more you see over here, the lesser actual height of the basement. So though you have dug up till over here, the actual basement that you are getting is only this much. Okay, so which is not very economical, not very feasible. So it is possible to start your pile cap from over here. Okay, and then whatever is required for the drainage system, it's so there are various permutations that are possible for to accommodate your drainage, and this is not the only one. That's the point I made. Yeah.
Got it.
The audio is clear, but the video sometimes takes time to load. Okay, we'll try to share the, but PPT I'll see, because PPT, many of the things I'm talking about is not available on the PPT. This is a combination. It's not a standalone kind of a presentation. No? I'll next time when I'm giving a presentation, I'll try to circulate the PPT so that you have this accessible. But yeah, video lag is a problem. Yeah. Okay. Any other question?
Vikram, when you were explaining how the retaining wall is constructed, so first there is brick masonry on the touching the mud, and then there is the waterproofing, and then concrete RCC is poured in batches. So between that there are construction joints. You said something about vapor. I don't remember the word. What did you
Yes.
say?
Vapor package.
Yes. What is that?
Now we talked about vapor pressures. So this is about, if suppose there is a construction joint over here at 1200 mm. So if there is a breach in the waterproofing over here, the water will come over here, right? And structurally also, this water will it will locate the most vulnerable. See, in waterproofing, it is very important to follow that maxim. The chain is as strong as its weakest link. Okay, I repeat, the chain is as strong as its weakest link, which means that if you have a chain, you do not consider the whole strength. If out of the 90 or 100 kind of links it has, even if 99 are strong and one link is weak, the chain is going to break at that point. Okay. Similarly, with waterproofing, you might do all your waterproofing extremely well, but on that particular day, that particular hour, your artisan, your worker, he missed out, and he missed out a small portion over here. And it happened to us when I was almost in 99. We were doing this job in SIS in Nerul. We did the whole waterproofing, and that was the first time we were trying the chemical waterproofing also, instead of box type waterproofing. The previous project we had worked with box type waterproofing, but this project, because of the time constraints, we had to go for chemical waterproofing, and we were assured by the company that nothing will go wrong. Now, yes, nothing went wrong as far as the chemical of the thing was concerned. But during the monsoon, the entire basement started flooding. Now, where did it start flooding? It started flooding where structurally there was a deviation which happened on the site because of the site condition. And that junction went a little lower than the waterproofing level. What I'm talking about over here, this was the waterproofing level. So over there, the sump or some portion structurally required, it went below this level. Now this portion was not adequately addressed. So the waterproofing, all the water started coming from one single point. The entire basement was flooded. Okay, so now the same thing can happen over here also. If this barrier, the construction joints are weak joints, we all know, Okay, because these are cast in two separate times. So if there is a water ingress which has to happen, it will happen from these vulnerable construction barriers. Now these construction barriers, they are vulcanized rubbers or neoprene kind of profiles. We'll share those. I'll try to locate those details. But these barriers are specially constructed using those vapor barriers. These construction joints are created using those vapor barriers. Yeah.
Okay.
That's it.
Yeah.
Okay. Apart from that, no. Have I left out any questions? Yeah, there was. Yeah, Advendra, how to repair it obviously is a construction or the conservation kind of a project. But is there a way of replacing the stone? Uh, Not relevant. Means in the sense that we either have to discard the stone, replace it with new stone, or we have to do injections with which we can restore the stone. Nothing more than that.
Okay, Vikram.
Okay. So
Yeah, I think it's fine.
yeah,
That's fine.
that
Yeah, I think as a at least the student have now some idea, because simultaneously Meenal is also handling basements by way of drainage and ventilation.
mm,
I do not know how many people are attend, because I find involvement of only a couple of students by way of questions. This is a complex topic. I really don't know how many are actually following it. If they are following it, nothing like it. If they are not following it, soon they will have to apply it. So once college reopens, they will soon have to design a basement and work both at the services and construction level. So their involvement, to what extent as of now, will reflect way back there. So that's. But I'm glad that there are a couple of them who are asking questions, at least are attentive. And out of 75 people or 73 people, we find only couple of them attentive. So that only time will tell. Yeah, the time will tell about how much they have been able to uh, concentrate and look at a 1 hour in a day. All we are asking is 1 hour in a day, and that 1 hour also, if you cannot give in some cases, then you'll have to give some explanation at that point of time. Yeah. Otherwise, fine. I think Vikram, we need to discuss something else. We can do that later on.
okay.
I think
Uh,
I think we may have
I'll
to make
skip this.
we can discuss some things later.
Yeah.
Yeah. Other than that,
Is there anyone? I mean, I just show of hands. If was this topic just taking a broad kind of a thing? Was this topic? How many people? How many people feel that the topic was very complex and they have not followed? 60% of it, even 60% of it. Show of hands. Okay, so which means everybody seems to have followed whatever was said. I'm
Yes,
not getting any responses. Yeah, okay. One. I just show of hands if people have followed what was conducted. Only 7. 11, 16. Forty. 43. 4. That's it. So out of 75, we have 58 raising hands. 59. So remaining 15 have not followed, or they are not attending.
Yeah.
Okay.
Time will tell. Vikram, time will tell. Finally, they have to apply this. So,
Okay.
fine. Whether they gather or not, it's I don't see when ICSE,
I am
CBSE,
I am
ICSE
super.
conducting exam. I don't think we will all have to go back to college and
I'm
I will
super
don
excited about
I will don
IPS actually.
beautiful mask with something and we'll conduct the studio happily. We'll know what could actually apply at that point. So if this is just an introduction, I just hope then they have to give an exam, semester 7 construction exam. So and all we are asking is 1 hour in a day to concentrate and if necessary asking. So fine, it's a learning process. It's a different learning. I do understand it may be a little difficult to grasp, but then, yeah. Next time we'll be taking diaphragm walls. We'll take diaphragm walls and multi-storied buildings and diaphragm walls.
Okay, Jimmy.
You're mute.
Thanks a lot. I said.
Yeah.
Bye.
You've taken the attendance, Vikram? Yeah.
Yeah, I've taken.
Yeah. Okay.
I'll
Okay.
just take it again
Stop.
maybe.
Thank you.
I'll just take it again. Just a sec.
Thank
Just a
you.
sec. I'll just take the attendance.
Yeah. Okay.
Okay.
We will talk to you on phone.
Thank you.
Okay. Yeah. Bye bye. Thanks.
Thank you.
Thank you, Jimmy.
Thank you, Vikram and Jimmy.